Right now, as you're listening to this, a cosmic storm invisible to the eye is streaming through your body. A storm centuries and even millennia in the making. It's not just you, it's everyone, everywhere, on every continent, in every city, in every home. This invisible rain is made of tiny, high-energy particles. Some have raced across the universe for millions of years, fueled by the immense energies of exploding stars and processes so extreme, so mysterious, that they still puzzle our brightest minds. These are the cosmic rays striking every square inch of our planet every moment of every day. Today, let's uncover just how deep this hidden connection goes and what it means for life, for technology, and for the future of space exploration. Cosmic radiation. It's one of the universe's greatest secrets, and you're a part of it right now. So, what exactly is this cosmic radiation? The story begins far beyond our solar system. Imagine an ancient supernova, an old star reaching the end of its life, collapsing, and then exploding with incomprehensible strength. In that single moment, the star hurls particles outwards, scattering them across the galaxy at nearly the speed of light. These cosmic rays are mostly protons, the building blocks of atoms, but they can also be heavy nuclei, a single iron atom fully stripped of its electrons, traveling through space at a velocity that boggles the mind. Other rays are born in even stranger places, the swirling maelstrom around black holes, the intense magnetic fields found in neutron stars, or perhaps cataclysmic events we've not yet discovered. No matter their origin, these particles set out on journeys that may last millions, or even billions of years, crisscrossing the universe, drawn along by the invisible magnetic fields threading through the fabric of space itself. Through all that time, through countless light years, a tiny handful will eventually intersect with Earth. When they do, despite their tiny size, they pack enough energy to make a difference. Cosmic rays are so powerful, in fact, that some have energies far higher than anything we can create here on Earth, even using our largest particle colliders. Their arrival is both continuous and relentless. You can't feel it, you can't see it, but as you walk through the park, ride the subway, or even lie in bed, countless cosmic rays are striking your body, passing right through you, or slamming into the atoms in our planet's atmosphere. You might wonder, just how often does this really happen? Every second, billions upon billions of cosmic rays pass not just through the atmosphere, but right through you. In fact, if you held your hand to the sky for a minute, a handful of these particles would pass straight through it, sometimes as if you weren't even there. Most are stopped high in the atmosphere, producing magnificent, if invisible, fireworks. The few that reach the ground are called secondary cosmic rays, the byproducts of a much larger cascade. Some cosmic rays carry so little energy that they barely interact with anything. Others have enough punch to alter the very code of life, snipping, rearranging, or damaging the DNA inside living cells. Our technology, too, is vulnerable. Sensitive electronics aboard satellites or even ordinary computers sometimes flip bits or crash programs, all thanks to a single, well-aimed cosmic particle. Don't worry. This phenomenon isn't new, and it's not about to throw life into chaos. The Earth, in all its wisdom, is not unprotected. Our planet is equipped with a mighty shield, one forged over 4 billion years and maintained by the restless churning of molten iron in our planet's core. This is our magnetic field, an invisible bubble extending tens of thousands of kilometers into space. Like an enormous force field, Earth's magnetosphere wraps around the planet, deflecting many of the most dangerous, electrically charged cosmic rays. Charged particles traveling near light speed, approaching from the depths of space, find themselves bent, twisted, and even trapped by these magnetic lines of force. Yet, not all are turned away. Some make it past this magnetic gauntlet and crash into the upper layers of the atmosphere. When they hit air molecules, nitrogen, oxygen, argon, They unleash a spray of secondary particles in a chain reaction. Pions, muons, electrons, and more, all fountaining, spreading out, sometimes reaching the ground far below. These collisions also unlock spectacular displays, the auroras. Near the magnetic north and south poles, where Earth's defenses are at their thinnest, some cosmic rays reach low enough to energize gases in the atmosphere, painting the night sky with flowing curtains of green, purple, and red light, nature's own radiant warning sign of the power from beyond. But what if you could step outside this protective shell? Imagine yourself as an astronaut, floating in the cold, bright silence of space, perhaps outside the International Space Station. Here, away from the majority of Earth's atmosphere, the cosmic rain is far more intense. Astronauts on the ISS receive as much as 10 times the radiation dose of those on the ground, even with careful shielding. For them, dosimeters are as important as oxygen. Their limit for exposure is closely tracked, because high doses of cosmic rays can damage cells, increase cancer risk, or even cause acute sickness if unprotected for too long. A trip to Mars will only make this problem worse. Once beyond Earth's shield, travelers on an interplanetary journey are exposed to nearly the full force of cosmic radiation. There, even the best-designed spacecraft must carry layers of thick shielding. Yet even that is often not enough. Bursts of cosmic activity, known as solar particle events, can cause sudden surges in radiation, dangerous enough to require astronauts to shelter in specially hardened compartments. Finding ways to survive and even thrive in this cosmic gauntlet is one of space travel's greatest and still unanswered challenges. Cosmic rays aren't just a hazard, they're also a profound mystery. Some of these particles arrive with energies so staggering, so deeply puzzling, that they shatter our theories of physics. Picture this: the Large Hadron Collider, buried under the border of France and Switzerland, represents the peak of human engineering. It smashes particles together at almost the speed of light, unleashing energies never before seen on Earth. Yet some cosmic rays, just a single proton or fragment of an atom, arrive with millions of times more energy than anything produced at the LHC. How is this possible? Where in the universe could such a natural accelerator exist? Some scientists theorize they are born from the collapse of galaxy-sized magnetic fields, from the energy released when supermassive black holes feed, or from mergers of star corpses. The truth is, we don't really know. Vast arrays of detectors are scattered across the globe, from the Pierre Auger Observatory in Argentina to detectors buried in Antarctica's ice, all seeking to catch and analyze these ultra-rare, ultra-high-energy cosmic visitors, hoping to unlock their secrets. It's easy to think of cosmic rays simply as a distant danger, something to shield against or avoid. But incredibly, these ancient cosmic particles might be part of the very reason that life on Earth evolved the way it did. Over millions of years, the slow, relentless bombardment of cosmic radiation has reached not just the ground, but deep into the organisms living here. Inside the nucleus of every living cell, cosmic rays can occasionally strike a strand of DNA, subtly altering it, flipping a base, or breaking a chromosome. Most of these changes are harmless, or even deadly to the cell. But every so often, a mutation gives an organism an advantage, helping it survive or adapt just a little bit better to its surroundings. Over immense timescales, these mutations, drip by drip, century by century, add up, driving the great engine of evolution. Cosmic rays, then, are not just a threat to life, but a source of its endless novelty. It's possible that, without this hidden cosmic influence, complex life, maybe even humans, might never have arisen at all. So, are we safe? On the surface of our planet, the answer is, for now, yes. Our ancestors, and every creature before them, have survived this cosmic drizzle for billions of years. Our thick blanket of air provides a buffer. Each meter of atmosphere above you absorbs cosmic energy, so that by the time it reaches the ground, its power is greatly dimmed. Our magnetic field, too, continues to protect us, though it wobbles, shifts, and sometimes even flips its polarity as the eons pass. For those of us on Earth, outside the highest mountain peaks or the coldest polar deserts, it's business as usual. But as we search for a future among the stars, returning to the moon, dreaming of Mars, sending probes to the icy moons of Jupiter, cosmic radiation will always be there, a silent, relentless adversary. No spacecraft can afford to ignore it. No Mars base can be built without considering how to survive it. The cosmic rain continues, patient and unstoppable. Space, in the end, is never truly empty. Even in the dark, between the stars, it is alive with motion and energy, an endless interplay of matter and force. Once the ancients thought rain and lightning only came from the clouds above. Now we know that the cosmos, too, rains upon us, a ceaseless, invisible cascade, shaping continents and cells and civilizations alike. Every moment, every second that you listen to these words, you are a part of a cosmic legacy, a connection not just to the earth beneath your feet, but to ancient exploding stars, to the violent births of black holes, and to the future worlds we'll one day visit. And as you pause, remember that you are living proof of the universe's boundless creativity and its enduring mystery. Thank you for joining us. Don't forget to subscribe and discover what else the universe holds. Tomorrow, we'll visit a planet of ice that's on fire. Yes, it exists. Until then, keep looking up. The universe has so much more to reveal.